Welcome to GIS for Disaster Risk Reduction, presented by the Florida International University Extreme Events Institute. In this course, you'll learn about the fundamentals of geographic information systems and explore their application in disaster risk reduction planning. During this semester, we'll learn about a conceptual and functional framework for starting small and simple with an eye toward enhancement and increasing sophistication and utility over time. We'll explore a range of freely accessible technologies that provide the ability to initiate this process for very little cost. We'll perform exercises with these software to get you over the initial learning curve and help you gain comfort in working with these tools. In this unit, we'll discuss the concepts being employed by this approach and walk through the contents of the course at a high level to prepare you for what's to come. My name is Nate Smith, and I've been working with GIS in the emergency management profession since 1992. You can see some of the high points here. What has perhaps been most interesting about my professional journey has been the breadth of experiences, from first responder to supporting high-level national geospatial efforts, from working extremely local to globally. I've supported communities in the U.S. with their needs to manage their bus stop inventories, for example, to helping countries make some of their first digital maps. I've been fortunately positioned to use the full range of geospatial technologies to provide insights and support decision-making from small rural communities to the White House in Washington, D.C. I've seen GIS used in simple and highly sophisticated ways and at a wide range of investment levels. What I noticed in this experience was the tendency of organizations and communities to use these tools in isolation, to the limit of the organization's mandate rather than addressing the full magnitude of the problem. They would develop singular products that have limited utility and short shelf life. I also noticed that many of the efforts were self-limited, as the organization would not seek to develop the partnerships and collaborations necessary to employ these tools toward a higher, longer-term goal. I also noticed an emphasis on response and recovery applications of GIS, and those tools developed for risk reduction were overly complex or not transferable outside the United States. This class aims to take those experiences and propose a new approach that's more holistic and collaborative in identifying risk with locally appropriate and sustainable tools for the long term. Please also note my contact information. I look forward to hearing from each of you during the semester. The course objectives listed here are also in the syllabus, but the key point is that we'll provide an introduction to the full range of activities necessary to employ GIS in a disaster risk reduction context, from understanding the software and all that's necessary to make it work, to considering how you communicate the findings of the analysis, and even walking through the process in a hypothetical community. Additionally, you'll gain sufficient understanding of these tools to evaluate the appropriateness of proposed GIS activities and advocate for their use within your communities. With successful completion of this course, we expect you will confidently be able to see the role of GIS in disaster risk reduction efforts and even design programs that allow your community to benefit from this technology and approach. Let's begin by setting the basic foundation. The geospatial approach is a method where problems are addressed in a manner that considers their location as one of the primary determinants of their significance. It's a concept where one starts problem solving with a map, rather than just using the map to communicate on the back end of the process. The early and ongoing cartographic visualization and spatial analysis is essential in addressing problems where location is critical, similarly to how graphs and charts are central to solving numerical problems. Conceptually, space provides a framework where otherwise disparate data can be aligned, compared, and analyzed. This information can be compared to other information and to the medium of space itself, as we'll explain later. With the ability to store and retain versions of data and data from multiple dates, the geospatial approach accommodates temporal analysis to see changes over time and even predict possible future states. GIS for disaster risk reduction is a concentration of the methods, tools, and best practices used in pursuit of safer communities. It leverages a wide range of skills and disciplines in the process and is structured to be inclusive of improvements as knowledge, technology, and understanding improve. In Unit 2, we'll take a deeper dive into GIS, but for now, this is a fast-evolving discipline that is allowing communities to take control of their risk awareness and with it, create a better understanding of how they may reduce that risk. Why are we proposing this? When exploring the MDAT disaster history database that goes back to 1900, it's clear that even when accounting for the increased awareness brought on by the internet, disasters and the damage they cause are increasing in frequency and cost. Early warning and education have reduced the proportions of people killed and injured versus impacted by these disasters, but the raw numbers are still climbing and are at levels that should be considered unacceptable. While this may seem depressing, we do live in a time where we have a wide range of tools and techniques at our disposal to better understand this risk and the expertise, engineering, and resources to mitigate much of the worst of these forces of nature. What is critical is that we make the effort to apply these tools to their fullest and make our best effort to reduce this risk and the consequences. While GIS has a long history in disaster response, and I have considerable experience in doing so, I will say that this is a band-aid approach and does little to save lives. We must look at the right side of the disaster continuum picture on the right of on the bottom right of the slide, and use the tools in the pre-disaster to a point where the disaster itself becomes less likely. Click on the graphic at the top right to see how the World Bank is looking at these challenges. The key assertion in answering why the geospatial approach makes such good sense for DRR is that all aspects pass the test of having location as a critical defining aspect. More importantly, the most basic definition of a disaster may be where a hazard and a vulnerability share the same location. This essential co-location aspect confirms that the geospatial approach is the proper place to begin. GIS is ideal for visualizing, recording, and storing information on hazards and vulnerabilities, but even more importantly, it provides a digital analytical platform for comparing these layers against each other to estimate a range of meaningful impacts, such as the impact and loss estimation, as well as predictive models to see what might happen in the future. As a digital platform, GIS allows for the user to study their community from a wide range of observation levels. By aggregating data, the community can be assessed as an individual unit, or neighborhoods can be used as a level of analysis. Finally, individual assets like medical centers and schools can be analyzed individually. If you're not yet convinced, we can summarize. This is a complex problem made more complex by communities having to concern themselves with many different hazards. Communities are dynamic, are in a state of continual change. Geospatial tools are ideal for this type of analysis and are getting more powerful, less expensive, and easier to use all the time. They're also scalable, so you can start small and grow big without losing the earlier investment. I hope you agree the case is pretty solid for considering this in all communities. When considering this approach, you should consider it a process rather than focus on a product. It proposes a change in the way your organization will operate and consider risk. This effort, once started, will remain active and will evolve and improve over time. It's not a one-off study, but a system that will be maintained and an analysis that can be run whenever needed. The effort is made up of discrete elements that together make up the entire system. Each of these can be upgraded or enhanced, replacing the previous. Also, the system can grow to include new areas and new capabilities. To start out small is not a problem. These two concepts, in combination with a process improvement plan, constitute a spiral development approach which will enhance capability over time while providing ongoing utility. Finally, remember to not let perfection be the enemy of good enough, meaning let's make positive progress, use what we learn responsibly, and improve over time. Let's make sure we have this concept of spiral development well understood. In our case, the core concept of hazard times vulnerability equals risk will remain at the core of all we do. However, there's a wide range of capabilities that can make that analysis more precise and detailed. By looking at this with a patient, long-term perspective, but not being held back from doing what's possible now, your efforts can move forward and improve over time. Let's take a short walkthrough of the units offered in this course. In this module, we'll provide the foundations of geographic information systems, discuss the key elements of people, data, hardware, software, and methods, and even load up a desktop software program and familiarize ourselves with it. This lesson will introduce you to geospatial data and provide some strategies for acquiring it from a range of sources. In Unit 4, we'll look closely at hazard data and understand the challenges and sources for discovery of this key input. In many GIS4DRR approaches, this would be more focused on vulnerabilities and would look at most community resources in that light. We will, however, take a different approach since most of the resources in the community can be vulnerable to disasters or useful in response. Thus, seeing them through a single lens of vulnerability is a bit of a simplification. We will instead make the case for them to be considered as assets, things the community owns and cares about, that if impacted by hazards can be vulnerable, but they can also be resilient and useful in a post-disaster context if they're still functional. Within the GIS software, we mentioned that the formula hazard times vulnerability equals risk can be executed mathematically. In Unit 6, we will explore the way this works and even conduct a simple exercise using the GIS system loaded up in Unit 2. Understanding risk within the leadership of a community is important, but communicating that to the citizens is critical as most risk reduction activities will be executed by the community acting in their own best interest. Exposing areas as being high risk can have unintended consequences on property values and land use rights. It's important that all communications of risk be validated and constrained only to that which can be confidently asserted. We'll discuss this in Unit 7 and even build a web map to communicate risk to a public audience. The use of GIS is growing rapidly, and many organizations around the world are using it or promoting its use for disaster risk reduction. We'll explore these groups in Unit 8 and conduct an exercise to thoughtfully plan who we should reach out to for collaboration in our communities. Finally, in Unit 9, we'll walk through a hypothetical community's efforts to implement this approach, and we'll see how they prioritize their hazards, identify partners, and plan their efforts. We will use the Blackboard course sites to deliver the content of this course, as you likely already know. All material will be disseminated through this platform or email. We can hit a few high points here. Here's a breakdown of the grading for the semester. As you can see, we'll have exercises, quizzes, and a project to complete before the end of the semester. This document will be our primary text, and a number of free online resources will be leveraged throughout the semester. You will not have to pay for a textbook this semester. These other documents are listed on the syllabus. Thank you for participating in this course, and we hope you'll enjoy and benefit from the content.